Alright, today's video will be talking about naming ionic compounds using the main group elements. The main group elements are the S and P block orbital elements, which are your first two columns and your last six columns. So you have the left side and the right side, and the transition elements, which are in the middle, are not used in naming of these compounds. So here's some examples. Alright, so we're going to be talking about how to write ionic compounds, and these were with the main group elements, which are the S and P, or the first two columns of the periodic table, and the P block element, which is columns 13 through 17. So the main group elements are your S and P sublevel elements. Okay? Now, the key thing on this that we need to worry about is that when we do create something ionic, we have something that has became, or something that is from a metal, and all metals will want to lose electrons. Okay, so elements that are metal will want to lose electrons, and when they do, they become positively charged. Nonmetals, which are on the opposite side of the periodic table, will want to gain electrons to equal out their outermost electron level. So they will become negative. Okay, so the key thing here is ionic, metal, nonmetal. Now we'll talk about covalent compounds here in another video. All right, so we're going to talk about first what would happen if I would bring sodium and I would make a bond with oxygen. Okay, knowing sodium, where it's located at in the periodic table, which we'll see here in a couple seconds, it will become 1+. Oxygen will become 2 negative. Now let's look at the periodic table to see exactly why this is the case. All right, the sodium is sitting in the first column. It has one valence electron and will want to lose one electron and become positive. Okay, so 1+, this is due to losing one electron. Now, the oxygen on the opposite side is sitting in a column in which it will want to gain 2 electrons to become 2 negative. So this is due to gaining 2 electrons. The main goal of any element is to lose or gain electrons, so it has an outermost level of 8. Okay? So we have losing 1, gaining 2. So in terms of their charges. So back to the example again. +1, -2 on the oxygen. So what we can do is we can do this an easy way, which is called the flip-flop method, or crisscross method, sorry. And what we do is we take the number not to charge and we crisscross that to the other element. Okay? So for sodium, which is +1, that tells me that I will have 1 oxygen in the compound, and for the sodium, which we'll have the 2 from the oxygen, we'll have then the formula of Na2O. This can only be done for main group elements in terms of those charges. So 1 will be the subscript of the oxygen, and the 2 will be the subscript of the sodium. So Na2O. There is your formula for sodium oxide. So sodium and oxide. Remember too, when we name ionic compounds, you do not say oxygen, we call it oxide with an IDE ending. Alright, let's try another one. Let's take beryllium and let's take nitrogen. Okay, so beryllium and nitrogen looking where they're at in the periodic table, we know that beryllium is in the second column, and it will want to lose 2 electrons and become 2 positive. So once again, this is 2 positive because it will want to lose 2 electrons. The nitrogen, which is on the nonmetal side, or in column 15, will want to become 3 negative. This is due to it wanting to gain 3 electrons. So back to our example again, beryllium will be 2 plus, nitrogen will be 3 negative, and if we do the crisscross method as we discussed earlier on, the 2 will be the subscript for the nitrogen, the 3 would be the subscript for the beryllium, and we would have a formula of Be3N2. Okay. Remember too, we're naming straight up main group elements. This is called beryllium nitride. Remember, not nitrogen, because all nonmetals will have an ID ending. Okay, so the key thing to remember here, guys, is when we're creating ionic compounds that the first column is always 1 plus, the second column will always become 2 plus. Skipping the transition elements, we jump over to where boron and aluminum is. Those are 3 plus. The carbon, silicon, germanium, we leave alone. Nitrogen, phosphorus be 3 negative because it wants to gain 3. Oxygen 2 negative, and the halogen 3 negative, and of course the noble gases have no charge at all. So anything positive has lost electrons. Remember, every time you lose, you become positive. A little bit of an opposite type of thinking there. So when you lose electrons, so 2 plus, like for beryllium or magnesium, means 2 electrons were lost out of the outermost energy level. So anything that becomes negative, so if something's 3 negative, like nitrogen or nitride or phosphorus or phosphide, which is just the ionic name for those, this tells me something has gained 3 electrons in its outermost energy level. So anything that wants to become positive will lose electrons and become positive, which is a metal, and this is become positive. So anything that's non-metal will want to gain electrons. And they will become negative when they do gain electrons. So the main thing you need to worry about with writing ionic compounds is that anything on the left side will want to become positive, even moving over into where boron and aluminum is, and anything on the other side will become negative because it wants to gain electrons. So metals want to lose, nonmetals want to gain. So if we would pick like rubidium, which is in the first column will want to become positive charged. In other words, it wants to become +1. If something like sulfur on the opposite side will become a sulfide ion, sulfur will want to gain 2 electrons and become 2 negative. I hope this video at least helped a little bit in terms of looking into how to write simple ionic compounds. There will be more videos coming soon on stock system. That is the using of Roman numerals to specify certain metals in the transition elements. And Hope you have a wonderful day. Any questions, please leave down in the comments, and I will try to answer as soon as possible. Thanks.